Hello and welcome to one of my past paper walkthroughs. So in this video I'm going to go over the 2022 past paper for the iGCSE Computer Science Paper 2. But before I do, please may I ask you to click that like button on this video, subscribe to my channel by clicking the subscribe button and sharing this channel and video far and wide. Without further ado, I'm going to go into walk through how to do the application for computational thinking, which is the paper 2 of the iGCSE computer science exam for the Edexcel exam board. I'm not going to read through the instructions because you can read all of this on the day, but there's the instructions. So in this one, only one programming language out of Python, C# or Java can be used. And one language has to be used throughout the whole examination. So you can't do one question on Python and then another one on Java, for instance. If you pick Python, you stay with Python. If you pick Java, you stay with Java. So total mark is 80. And let's get into the questions. So you'll even have the instruction. Use only one programming language throughout the examination. So we need to use a cross in the box. In this video, we're going to do Python. So let's start with question 1. Programmers write code to solve problems. So we need to identify the description of a variable in a computer program. It's a value that can actually change. So that's all it is. It's a value that can change. But if we were to have a look at the mark scheme, the answer is D. So it's a value that can change. Second one, identify a technique that improves the readability of code. It would be to use indents on every line and use descriptive names of variables. But the answer that they're looking for is B, which is using descriptive names for variables. So you make it meaningful, if you like. So using meaningful names for variables. Okay, next one, we're going to complete the table by giving an example for each data type. So we've got the first row done for us. So integer data type, an example value is going to be 12, because that's a whole number. If we were to do characters, it can be capital A, lowercase a, or it could be a symbol like the @ sign as if you're writing an email to somebody. Or it could be a real. A real, in Python we would write it as a float input, which it means decimal numbers. So it could be 4.5, 35.5, 10.4, 8.7, etc. Okay, D. Describe one difference between the data used in boundary testing and data used in erroneous testing. So the type of answer they would look for, in this case, boundary testing uses the most extreme data, that would get you 1 mark. Whereas erroneous testing uses invalid data. That would get you another mark. So there's not much you could do there after that. So what you've got to remember is it's just copy and paste the mark scheme. They'll ask you the same question, word it slightly differently, but it's copy and paste the mark scheme. Okay. Number E. So part E, a program should output a value of 2. However, there's an error in the code and the actual output is 4. So this type of error, we would write logical error. So a logical error is a type of error where the program works, but it outputs something completely different to what we thought it was going to output or what we intended to output. Syntax error would be the code doesn't work. Now for the first editor questions. So we need to open Q01F in the code editor. So I'm going to open this up. And this is a nice one. Because in a question like that, we would have to figure out what's wrong with the code. But let's read the question before we answer it. The program should allow the input of the length of the side of a square and output the area of a square. There's 3 errors that we have to correct. So if we get one error, address one error, we get 1 mark, as this is 3 marks. So the first error to address, length equals float, 1 bracket input, 1 open bracket, enter length to the side, and you'll notice you've got 1 closing bracket. So if you've got 2 open brackets, you've got to have 1 closing one. Done. That's 1 error done. That's 1 mark. We've got area equal to, so we don't use relational operators / comparison operators. You only use that if you want to check whether a number is greater than or equal to or is equal to. In this case, we only want the 1 equals. So that's given us area equals length times length. That's 2 marks. 2 errors done, corrected, 2 marks in the bag. Now we want to print the area, but we're not going to get it like that. So what we can do is we can just highlight, cut, paste. Run it. So I'm going to enter a 4, 16, 4.2, 17.64. And that is all 3 errors corrected, so that's 3 full marks right in the bag. Nice and easy stuff. Let's get 1G on the ready. So 1G is slightly more difficult because it's going to be more involved. But let's see what 1G is. A program is needed that will accept the input of a letter and compare it with the stored letter. So it's going to check whether the letter comes early in the alphabet, later, or is the same letter as the stored letter. So it's going to output the letter and the stored letter with the appropriate message. So we've opened Q1 in the code editor, so I've got the code ready. So we just need to amend the code to complete the if statement used to produce the output, and no more. So that's all we got to do there. And there is, so what can we do here? So we could have a look at the stored letter and the stored letter. So we could have if letter is greater than stored letter. Then we're going to do a print statement, which is going to say the letter. So the letter that is stored. So the letter that we've inputted, so we're going to have letter, is after the stored letter, which is stored letter. And then we could just have those. elif is before it, and that's the same. So elif, letter, coming before the stored letter, so it's less than stored letter. And then we've simply got else. So let's see that in action. So I'm going to enter a G. It's equal. It's the same. If I was to go in and enter a T, it's after G. If I was to press run and I was to do D, that's going to be before the D. So we've done 3 tests, and we know this program works like a charm. So we know that works. So I'm going to bung that here somewhere, ready for later on. So I always like to keep a record. It's always good to keep a record of all the code you've ever done. Just bung it in a Word document. At least you've got something. Okay. That's all the question 1. Number 2. Browser's writing the program to tell the user whether the number they input is a prime number. Prime number is a whole number larger than 1 and can only be divided by 1 and itself with no remainder. So this is the pseudocode. So this is the pseudocode, which I recommend you spend a little bit of time reading I'm trying to recap, okay, what's this bit mean? So you got to do that. Because these questions is going to ask us about it. So we need to identify a line number where selection starts. That's 1 mark. So let's look at where selection starts. So one starts at line 3, one starts at line 8, one starts at line 20. They're your if statement. That's where our selection starts. Next one, identify the line number where iteration starts. So iteration is loops. So we got one that starts at line 7. That's where our iteration starts. Nothing before, no less. So now we need to identify a line number where a string and a number are printed on the same line. So if we have a look at the pseudocode, you can see that it starts on line 21 and on line 23. Because you've got the number, which is your integer, and then you've got is a prime number or not a prime number, they're strings, and they're on the same line. Okay, let's identify the name of a local variable. So a local variable is only within the subroutine. So in this case, it's going to be check, and it's going to be p number. So those are the two variables, local variables in the code. And you could also have count in there. You don't have those anywhere outside the program. Number 5, identify the name of a parameter. So the name of the parameter is p number. Because you've got the function, check prime, and p number is the parameter we passed into it. And that is everything. It's always worth checking our old friend the mark scheme. Yep, so we got all 5 of those exactly right. Let's move on to B. We need to write the program to implement the logic in the pseudocode. So we need Q02B. So let's have a look at this Q02B. So what we need to do in this one is we need to use the structure given in Q02B to complete the program and only do what's up there, nothing else. So let's have a look and see how we're going to do this. So the handy thing about programming papers is we can look at the pseudocode as is, and there we go. So I'm going to write a function, def check prime, and pass p number into that. And then I'm going to do if p number is equal to 1, then I'm going to do a Boolean variable called check and set that to false. Else, check is going to be set to true. And then you could do for count in range 2 to p number. So what's going to happen in there? We're going to do if p number modulus count is 0, then we're going to check that as being false. And then we're just going to return the check. So that's our subroutine done. Next one, I'm going to ask you to enter a number. So you can have number, int, input, enter a number. And then it's going to receive the number, and then we're going to set the result to check prime, and we're going to set that to number, to the number variable. And then we're going to have if result is equal to true. Remember, it's got to be a capital T for true, capital F for false, not lower. And then we just say that's a prime number. So let's see how that's going to work. So I'm going to say 2, that's a prime. 1, that's a prime. 3, that's a prime. 4, that's a prime, not a prime. 5, prime, 6, not a prime. So that is a fully working bit of code there. So I'm going to make sure I do this. Question O2B. Should have done that one. O1G to O2B. Yep, always handy to just keep the code that you've ever done. And that, nice and done. Nicely done. Let's look at number 3. Number 3, Magic sells copies of a science textbook to school. She needs to program to process textbook orders. So we have to accept the input of number of textbooks required, generate the price per textbook, and generate the total cost of the order, and display the price per textbook and the total cost of the order. So we have to do that functionality based on the information given and no more. So let's see what they've got. So they've got that. So how are we going to do this? So in a question like that, we could do a variable called cost, 0, price, 0, quantity, 0. And we could have total being 0. Then we need to print a prompt. So we need a variable called quantity, and we're going to do int input. Enter how many textbooks you want. So it's going to ask the user to enter the textbooks. Well, let's make sure there's no syntax error there. So what we could do there so we've got our variable called quantity. And now we need to do some if statement. So if quantity, so it's going to be greater than or equal to 1. Greater than or equal to 1. And quantity is less than or equal to 5. And then we're going to set the price as 20. We're going to do elif quantity is greater than 5 and quantity. So we do elif quantity is less than 10. Price is going to be 15. Else price is going to be 10. The price is going to be 12 actually. So that's what we got there. So then what we need is the total. So total equals price times quantity. Then we're going to do a print statement. The price per textbook, that's our price. The total cost for the purchase is. And the total cost is going to be just total. Let's run that. So I want 3 textbooks, 60. I want 7, 15, so that's 105. And I want 25. So that is our working code, which I'm going to save that into my Word document because I like to have a collection. Q03 That's what I like to do there. And that is our code. Nicely done. So now, let's move on to number 4. We've got several encryption algorithms have been developed. So we need to identify what is meant by encryption. Process of elimination. You're not converting ciphertext to plain text. You're not converting code into data, and you're not converting data into information. We're converting plain text into ciphertext. So B is the correct answer. If I would have said what is meant by decryption, then it'd be conversion of ciphertext to plain text. But for now, as it's asking what encryption is, it's conversion of plain text to ciphertext. Let's look at figure 1. So it shows a pigpen cipher grid. So we need to complete the table, adding the symbol for each letter in the word may. So let's have a look at M. So we got M. So the symbol for M is going to be that L with the dot. With the dot, right? So basically below, so just below M on the right. What about A? A is going to be the upside down L. And then let's look at Y. It's not going to be any of these two grids. S, T, U, V, nope. W, X, nope. There's Y. So it's the leftward facing arrow with the dot going leftwards with a Y. So they are the 3 symbols that we need. Okay. Now we got the message the enemy is near, and it's encoded using a different encryption algorithm, and figure 2 shows it. The stages in the first stage of the encryption process. So we need to give the key used in the first stage. So what it's going to do in this case is going to go TIHYS, then it's going to go EMN. It's going to keep going line by line. So that is how it would work in this case. But let's go back up and check. So yeah, it was 5. So we said the first one was 5, and the second one was TIH. So they're right. And then we need to give the name of the encryption algorithm that's been used to produce a ciphertext, and that's a rail. So rail is also called a fence cipher. And then that's our 7 marks. Now we've got a gaming club one. So Julia runs a gaming club. She wants a program to check the passwords stored in the file. So you've got the file password text. So this is the file we need. So that's what we need. So you've got the alphabet going from A to Z, all in uppercase letters, and the valid digits going from 0 to 9. And we've got the password file, which we're going to open, where we open the password.txt, and it's set to R, which means read. So we're not writing or appending, we're just reading the file that's there. And this is a bit where we will need to add our code. So, the program has to check the password to ensure the first character is uppercase and a digit has 1 digit. If the password doesn't, we display the password and we increment how many incorrect passwords there are. Then we display the total number of incorrect passwords after all the passwords have been checked. So we've got Q05A open, and we have to use the structure given in Q05A to write the program, and just doing what the question says, no more, and no more than that. So, luckily I've got an example. So we need incorrect passwords is 0. And then what we need is for, so for password in password file. So that's a bit we need. And then we need valid, and we're going to set that to false. And then we are going to do if password, I'm going to do that to 0. And this is where we can bring in our, and if it's in alphabet, if it's in the alphabet, then we're going to do index, and we're going to equal that to 1. So while valid is equal to false, and index in range, so we're going to go for 1, 2, we're going to use the len function to get the password. So while that's happening, we're going to do if password is indexed into digit, it's going to be, that's actually going to be valid equals true. Otherwise, it's going to be index equals index plus 1. Okay? And then we're going to have outside the if, so if not valid, so not is a logical operator, so we're going to have incorrect passwords equals incorrect passwords plus 1, we're incrementing that. And then we're just going to print password. And then what we're going to do is we're going to do, we're going to print incorrect passwords are incorrect. And then we're going to do password file dot close. So that will close the file. So then we're going to run it. And we can see we've got lots of incorrect passwords going on here. So let's run that again. Yep, so we found 31 passwords are incorrect based on what we found in the password.txt file. Okay? And that's our code. Okay, so B, we got figure 3, shows an array that stores the player scores after a game. So we've got 3, 2, 10, 8, 1, and 9. Julia uses a bubble sort algorithm to sort the scores. So we've got to complete the table of how the bubble sort algorithm will sort the scores. So the number of rows there are, it looks like it's too many. So don't think you need to be using all the rows. You can do, but you don't need to. So in this one, we need to think about the sorts. Now, okay. So the way we would do that, so you could do 2 and 3, so they swap. So 2 is less than 3, so they're going to swap. Then we'll have, so they're going to swap, so 10 and 8. So there's going to be 1, 8, 9, and 10. So that's sort. That's one sort. Then we're going to have 2 and 3 again. And then what's going to be there before that? So 8 and 1. So we had 8 and 1. So they swap over. Then we got 9 and 10. Then we're going to have 2 and 3. So 2 and 3. That's going to. So we got 2, 1, 3, 8, 9, 10. Then we're going to have 1, 2, 3, 8, 9, 10. So that's taken 4 sorts So sort those 6 numbers out in ascending order, in numerical and ascending order. Okay. Part 2. Explain one reason why a bubble sort is very efficient in terms of memory usage. So that's 2 marks. 2 easy marks there. So all the sort and swapping operations are done on the original data. And it also uses less memory. So an answer you could have, the list doesn't need to be split, which would use more memory. So you could say, less memory is needed, and the sorting is done in the same place as the original data. So those are some of the, so you need 2 out of those 6 answers you could have. So you've got a lot of options in this case. Let's say now, for C, we need to describe the steps a linear search algorithm takes to find the search item. So we need to begin at the start of the list. So that's the first place we go. So we go to the start of the list. Then we're going to compare, and the marking will have, you need to compare each value in the list with a search item, and then you repeat until the match is found. So you start at a list, compare each value that's there, and then until a match is found. If it's found, then the search stops. Otherwise, it's going to keep going through the numbers, and then once it can't find anything, the search finishes. Okay? So that is question 5. Question 6 is a big beast. So the first thing I'm going to do before going into it, I'm going to get Q06. Because it is a big beast. We don't need the passwords file, and we don't need that now. So, what are we doing with this code? We got the first subroutine, generate passwords, passing pwords parameter to it, so we don't need to worry about that. These we don't need to worry about. We got the array of words. We don't need to worry. Add in the main program here and add in the subprograms. They're the places we do need to worry about. So, what do we need to do? So, we need an animal guessing. game. So, Carlos wants you to create the guessing animal game. The code contains an array of animals, which we've got, and it has a function that randomly selects an animal from the array. And this is a secret word the user needs to guess. So this is a big beast of a program. So Carlos wants the program to generate the number of attempts the user has to guess the secret word. Maximum number of attempts is the length of the secret word plus 3. For example, the user has 8 attempts to guess when the secret word is tiger. So that's 5 characters. We've got to keep track of the letters from the incorrect attempts, the secret word, and those that are not. We cannot have duplicated letters. So we display the message telling the user number of letters that go on the secret word, how many attempts left. Then force the user to input a word that's the same length as a secret word. And then check whether the input word matches that secret word. So if a word matches, message includes the secret word and the number of attempts taken to guess it is displayed. If the words don't match, then the letters from the attempt that appear in the secret word should be added to the correct letter store. And then the letters from the attempt that don't appear in the secret word should be added to the wrong letter store. And then the contents of the correct and wrong letter stores are displayed. And we're to allow the user another attempt until they've guessed the word or have run out of attempts. And we're to display the message telling the user the game is over, including a random word if the max of attempts has been taken and a word hasn't been guessed. So this question is worth 20 marks. So if you get it all right, you get 20 marks. But if you don't get it all, don't just ignore it. attempt it, if you get some of your code working, you will still get some marks. You're not going to get all of it, but you will get some, which is better than none. So how are we going to do this? So we could do the def, and we could do a program like, so we want to do check. So we want to do something like check input pguess. So that's the first thing we want to do there. So it's a fully completed function that takes the guess. So we want to validate that. So we want to check. So we want to check, and we want to initialize that to as a string. And then while len is the check, we're going to want a p word length. So instead of having p guess, we want the p word length as our parameter. So while len check is not equal to p word length, it's going to ask us to check, say what the secret word has. So it's going to say how many letters it's got, and then it's going to return the check. That's one subroutine. So now we want another one. I'm going to call that check letters in Word, and we want a series of parameters. So we want pguess, p word to guess, and we want p letters and type. Big fun, not a big one. So I'm going to show you the whole bit. So we want 4 letter in pguess. So we're going to check each letter in the guess. If a type is 0, then we're going to do an if statement. So if letter in p words and letters not in p letters, it's going to do increment the p letters. Which is something we need here. And if letters not in p word to guess and letters not in p letters, again it's going to increment either way. And then we're going to return the p letters. Then the next subroutine we want is def display. And we are going to pass p correct letters, p wrong letters. So that's what we're going to do there. So it's a fully function. I'll display the current status of the game. So we want if len p correct letters is greater than 1. Then we're going to do print statement. We are going to do okay. Correct letters, p is going to be p correct letters. So this is saying how many letters are in the secret word, and if not, it's going to go into if len wrong letters is greater than 0. So we've got the p correct letters and the p wrong letters. Okay. Yep, that's close, so that's fine. So we've got the subprograms. If we were to test it, we wouldn't be able to do that because it's not going to work just yet. Because we need the main code now. So we've got our array of words, and we need a secret word, and we need these variables. So we need the secret word to be generated, and we're going to add our own code. So we've got the secret word. We just need the word length. Len equals the word to guess. Maximum attempt is word attempt plus 3. Number attempts is equal to 0. We've got both correct and wrong letters equal to empty strings, and a guessed is false. So now we need a loop until the no attempts are left, until there are no attempts left, or the secret word has already been guessed. So this is what we want. So we want while num attempts is less than max attempts, and so we're using the AND logical operator, guessed is equal to false, comparison or relational operator. So we've basically said we have max attempts minus number of attempts already done to guess the secret word, and the num attempts is going to increment. Then we're going to get, then in the guess, we're going to get the user to check input, passing in the word length. And if guess is equal to word to guess, guess is going to equal to true, and it's going to say well done. Otherwise, it's going to increment how many correct letters are 0, and the wrong letters is going to increment. It's basically going to be a 1. Then we're going to display correct letters and wrong letters. And then we're going to, but if attempts run out or the secret word hasn't been guessed, we're basically going to say this was the correct secret word. So let's run it. So I've got 6 letters. So I'm going to say badger. Is it 6 letters? Right, 8 left. What am I going to say? Wombat. So I've got E, O, and M. Okay. Which is going to be a bit harder. I could say monkey. And that's given me all these attempts. Let's have another try at this fun game. So 6 letters. I'm going to say monkey. Not so I can't have that. I could say wombat. So Eba. So what can I have for Eba then? Badger. Yep, 3 attempts. So nice little way that they do those little clues. So that's question 6 of the game. So first attempt could be, but sometimes because this is random, you're not always going to get what's in this table. First attempt being dog, correct store being O, wrong store being D and G. Service to do cat, correct stores being C, and these are the wrong stores which increment. So unfortunately, they won't give you a chance to test this exactly, as this is based on the import random. So the secret word can be anything, completely random there. And that is the whole paper. The 2022 iGCSE Computer Science paper for the Edexcel exam board. The international one anyway. I hope you've enjoyed this video. Please remember to hit that like button on this video, press that subscribe button to my channel, share it far and wide, and I look forward to making another video for you pretty soon. Thank you for watching. Goodbye for now.